Every photo you've ever taken, every message you've sent, every movie you've watched, all of it reduced to just two symbols, 0 and 1. A lifetime of memories, emotions, and ideas, compressed into a language so minimal it barely seems alive. But why? Why does the digital world run on the simplest language imaginable? Why build our entire technological universe on a system that feels almost primitive? And if computers are so powerful, why not something richer, more expressive, more human? To answer that, we have to go back. Back to the earliest days of computing. Back to the moment when engineers faced a choice. How do you teach a machine to think? This is the story of why computers speak binary. A story of simplicity, reliability, and the strange elegance of a language made of almost nothing, yet capable of building everything. Imagine you're designing a machine that must never misunderstand a signal. Not once, because one wrong interpretation could crash a rocket, corrupt a bank account, or destroy years of work. Electricity, the lifeblood of computers, is messy. It fluctuates. It's noisy. It's unpredictable. So engineers needed a language that could survive chaos. A language that even a shaky electrical signal couldn't confuse. They stripped communication down to its absolute core. Is there voltage or is there not? A pulse or silence? Something or nothing? Two states. Clean, reliable, impossible to mix up. From that simplicity came a breakthrough. If a machine only needs to distinguish between on and off, then it can operate in storms of electrical noise and still understand every instruction with perfect clarity. That's why binary isn't just a choice. It's a shield, a defense against the unpredictable nature of the physical world. And from that shield, the entire digital universe was built. And that language was binary. Two states, on or off, high voltage or low voltage, yes or no. Binary is the ultimate survivor. It doesn't care about tiny electrical imperfections. It doesn't need precision. It just needs a clear difference between something and nothing. From room-sized vacuum tubes to microscopic transistors, every switch in a computer is happiest when only has to choose between two states. Binary isn't just simple, it's reliable. And reliability is everything. Because once you have reliable switches, you can start combining them, linking them, arranging them into patterns that represent decisions, comparisons, and choices. A single switch can say yes or no, but a network of switches that can add numbers, store memories, follow instructions, even simulate logic itself. Bit by bit, these tiny on-off decisions become the foundation of everything digital. From the text you're reading to the most advanced artificial intelligence, all of it built on the quiet confidence of binary. A language so small, it can hold the entire world. So why not build computers that use more than two states? Why not 10 levels of voltage? Or 3? Or 17? Well, we tried. The more states you add, the more perfect your hardware must be. And perfection is expensive and fragile. Imagine a decimal computer with 10 voltage levels. One tiny fluctuation, one bit of electrical noise, and suddenly a 7 becomes a 6. Or a 3. Or nothing at all. Ternary computers existed, like the Soviet Ceton. They worked, but they were harder to build, harder to maintain, and ultimately not worth the trouble. Binary wins, because it's the perfect balance between simplicity and power. And once binary took hold, something else happened, a kind of evolutionary lock-in. Every new invention, every breakthrough, every generation of hardware was built on top of the binary foundation. Logic gates, memory cells, processors, operating systems, programming languages, all of them designed around two states. Changing that now would be like trying to rebuild a skyscraper, starting from the 50th floor. Possible in theory, catastrophic in practice. Binary became the bedrock of computing, not just because it works, but because everything we've built for the last 80 years assumes the world is made of zeros and ones. And as long as that assumption holds, binary isn't just the best option. It's the only one that makes sense. But binary isn't just practical. It's elegant. With only two symbols, you can represent every number, every letter, every color, every sound, every idea. A pixel on your screen? Binary. A song? Binary. Your entire digital life? Binary. It's the alphabet of the digital universe. And from that alphabet, we write everything. We paint worlds. We simulate physics. We store memories. We build intelligence. All from patterns of zeros and ones. Patterns that look meaningless on their own, but together form the most expressive language humanity has ever created. Because binary isn't really about zeros and ones. It's about structure. It's about possibility. It's about taking the simplest building blocks imaginable and arranging them into something infinitely complex. Just like DNA uses 4 bases to build every living thing, binary uses 2 states to build every digital thing. 2 symbols, endless combinations, infinite potential. Binary is proof that you don't need complexity to create complexity. You just need the right foundation. So, will we ever move beyond binary? Maybe. Quantum computers don't think in zeros and ones. They think in probabilities. But even they rely on binary logic for their input and their output. Binary isn't just a choice. It's a foundation, a starting point for everything we build. And foundations have power. They shape the architecture above them. They define what's possible and what isn't. Even the most advanced technologies we imagine, neural computers, biological processors, quantum networks, all of them still translate their results back into the same ancient language, born from flickering electrical signals. Because at the end of the day, humans need clarity, machines need reliability, and binary gives us both. 2 states, 2 symbols, a simple contract between us and the machines we create. As long as we need a bridge between the physical world and the digital one, binary will be there, quiet, dependable, invisible. Not the future of computing, but the ground it stands on. The world runs on a language with only 2 words. And in that simplicity, we found infinite possibility. Binary didn't limit us. It set us free. Because once we embraced those 2 symbols, we unlocked a new kind of creativity. One where imagination isn't constrained by the physical world, but amplified by it. With binary, we built machines that could remember. Machines that could calculate. Machines that could simulate entire realities. From nothing but patterns of zeros and ones, we turned electricity into thought. We turned switches into logic. We turned logic into software, and software into the digital age. Every breakthrough, every invention, every leap forward in technology traces back to that same quiet foundation. 2 states, 2 symbols, a simple idea that became the engine of modern civilization. Binary didn't just shape our computers. It shaped our future. And as long as we continue to dream, to build, to push the boundaries of what machines can do, those 2 symbols will keep carrying us forward, guiding us into whatever comes next. Thanks for watching, and I'll see you in the next chapter of this digital adventure.